My dear friends, welcome back to B-Spice. In this session, we'll discuss about high integrity pressure protection system. We call it as a HIPS. So this is the configuration. So the point to note here is two valves are connected in series. Okay, and you have the initiator, and based on the pressure high and this logic solver will initiate the command to close these valves. So the funda is here. It will close the source itself. Normally, how we do the pressure protection in terms of relief valves, right? PSV, PRV, right? And also flare system. So that and all release to the atmosphere, right? So, but here it will try to reduce the, shut down the source itself. So that is the difference. Here also I can see, you can see here, two valves in series, you have initiators and the logic solver. Okay. Let us see what is HIPS and in what way it differs from the, what do you call, conventional design. Okay. So in a conventional design, a pressure safety relief valve, meaning the relief system, whether it's a PSV or PRV, were used as a primary means of protection. And of course, a flare system was used to safely combust the gases relieved during the overpressure event. This all we know, right? Yes. So, but what is the problem with this? Because we need something more robust. Okay, so why we need something robust? Due to increased design pressures and increased flow rates and environmental concerns. That's also the overall risk factor associated with the modern day plants and processes. So these are the factors which mooted the idea of something having something different. So that's why this HIPPS HIPS come into picture. Okay. In an industrial plant, as we know, the flare systems are primarily used for burning of the gases, right? Released by the pressure relief valves during the unplanned over pressurization of plant equipment. This we all know, right? Okay. So flaring and venting constitute significant source of greenhouse emissions, right, friends? Right. So HIPS can be employed to prevent overpressurization. That is the point, okay, of the plant by shutting off the source of the high pressure gas, okay, rather than releasing it to the atmosphere. So that is the point. HIPS can be employed to prevent overpressurization of a plant by shutting off the source of the high pressure gas rather than releasing it to the atmosphere. So that's the point here. I hope it's clear, friends. Okay, good. So HIPS provide this critical assurance in a safe and environmentally friendly manner. So that is the beauty. Okay. These systems are used when application involve high pressure flow rates. That is the point. Okay. Chemical reactions, multi-phase fluids, or plugging make it difficult to properly size a relief valve. Of course, we are sizing it, but we have our own challenges. Yeah. So HIPS, the high integrity pressure protection system, is a typical type of SIS actually, which is specifically designed to prevent overpressurization of a plant, such as chemical plant or refinery. Okay, friends? See, once it's overpressurized, you release it to atmosphere using, PSV, all these. Okay. But here, it's specifically designed to prevent the overpressurization of a plant. Okay. That's the point. So HIPS will shut off the source of the high pressure below the design pressure of the system is exceeded, thus preventing the loss of containment through rupture, meaning the explosion of a line or vessel. You got it, friends? So that is the beauty of HIPS. HIPS. Okay. So therefore, HIPS is considered as a barrier between a high pressure and low pressure section of an installation. Okay, friends. So this are, I hope this is also clear. Okay. In a traditional system, overpressure is dealt through relief system. This we all know, right? A relief system will open alternative, outlet for fluids in the system once the set pressure is exceeded, like, PSV, PRV, all this. What for? To avoid further buildup of pressure in the pressure in the further buildup of the pressure in the protected system. Sorry, buildup of pressure in the protected system, and this leads to a flare or venting to a safety dispose of excess fluids. This is the relief system, right? A relief system aims at removing excess of inflow for safe disposal. That is the point. Relief system aims at removing any excess inflow for safe disposal, whereas HIPS aims at stopping the inflow of excess fluid and containing them in the system. So that is the beauty of this HIPS. I hope this is clear, right, friends? Okay. Conventional relief system have disadvantages. What is that? Such as release of flammable, toxic process fluids or their combustion products in environment, and often a large footprint for the installation. Of course, you need to, have your own system, right? Yeah, so that's and all is a disadvantage. Okay. With increasing environmental awareness, relief systems are not always an accepted solution. But because of their simplicity, relatively low cost and wide availability, conventional relief system is still often applied. Still, we are still using it. I'm not denying. Still we using it. Okay, friends. So that's it. Yeah. So now, since HIPS is a type of SIS, the requirements of HIPS application must be investigated thoroughly. Okay. The SIS standards are performance based or performance based with the SIS standards are performed based on the SIL integrity level as a primary performance measurement. Of course, we have talked in detail about SIL actually. If you are a first time viewer, you can watch actually. In fact, this is a video number 208 actually. There are many videos related to instrumentation. Of course, the detail engineering uploaded. And one among this is the SIL classification, verification, the basic concept, all are there, friends. You can watch and get benefited. So the point is, the SIS standards are performed based on the SIL as a primary performance measurement, right? So basically what it represents, SIL represents a necessary risk reduction as recognized in users risk reduction analysis, right? So each SIL corresponds to the tolerable probability of failure on demand, PFD, to all HIPS devices from the sensor through logic solver and final element, which we have seen in the first slide, right? Okay. So of course, international standards like, IEC 61508, that is for the manufacturers, vendors, and IEC 61511, that is for, the implementation end user, and IEC 61131, that is for, the programming part, okay. And US standards like, ANSI ISA S84.01 are intended to address the framework for design, application, through the definition of assessment, design, validation, and documentation. This is just an information, friends. Okay, that's just information. Yeah. Now we'll go into the exact detail actually. Basically, friend, HIPS actually includes flow line barrier, valves or pressure transmitter or controls, designed to protect against the overpressure in the pipeline. So that is a funda, a basic design. It includes flow line barrier valves or pressure transmitters, yeah, and pressure transmitters and controls. So that is the, combination of this, what do you call, configuration of the HIPS system, okay, which we have seen earlier also, right, in the first slide. Yeah. So the module's control system monitors the pressure of the fluid flowing through the pipeline to the host platform. Okay. So through the hardwired logic, the control system automatically close the valve if the pressure fluctuation exceed a predetermined value in a flow line. Very simple, isn't it? Yeah. So here the point is, HIPS typically utilizes dual services in 1 out of 2 configuration, meaning 2 valves in series. As you can see here, 2 valves in series in conjunction with 1 out of 1 and 1 out of 2 solenoid valves. See, you can see here, this is the illustration of final element showing 1 out of 2 valves, right? 2 valves, right? And 1 out of 1 solenoid valve. Yeah, you can see here this combination 1 out of 1 solenoid valves. Similarly here, final elements 1 out of 2 valves, and here as you can see here, this is 1 out of 2, 1 out of 2, as you can see here, 1 out of 2 here. Okay. So this is typical configuration, friends. Just remember this. Okay. Now, each solenoid can also be connected in 2 out of 2 configuration. As you can see here, this gentleman is connected to 2 out of 2 configuration to reduce the spurious strip by having, 2 independent output logic, output 1 and output 2, 2 output logic, okay, from the logic solver. So that is the point. Okay. So this is the redundant one. Okay, friends, redundant. Yeah. So sensors that detect the high pressure logic solver which process the input to an output to the final element, right friends? Yes. So final element that actually perform the corrective action in the field by bringing the process to a safe state, right? So in case of a HIPS, this means shutting of the source over pressure, source of overpressure. That's it, friends. Very simple, right? So flare, pressure happens, then after the depressurization happens, then it actually, releases, right? But here it cut off the overpressure itself actually. Okay, friends. So that's it, friends. I hope it's clear. Thanks a lot and take care. And if you like this and if you, find this is useful, you can show your support either by subscribing or what do you call link. You can press the thumbs up button. Okay, friends, see you and take care. We will see in a new other video. Okay, thank you. Take care. Bye bye.